If you have been following my class on physics, you know that this is not the first class on motion. And in case you are still wondering where your child will be in the forthcoming WAEC classes, as a supplementary class for their WAEC, Dream Dreams Tutorial Center is the best class to be. Or you will think that the distance is far, we have an online presence. Or you want to come physically, 4 Mega Olopojede Crescent, Berikpe Road, Ikorodu, Lagos is our physical presence. Or our online presence is the number is displayed on the screen. You can watch it over here. So let's begin. I'll continue our class on motion. Or you still want to watch more of our videos on our YouTube. Taiwo Michael Duebo is the page to be on our YouTube, or follow me on this channel, Taiwo Michael, on Facebook. Let's continue our class on motion with this class. This is past WAEC question 2014. A body at rest is given an initial uniform acceleration of 8.0 meters per second squared for 30 seconds, after which the acceleration is reduced to 5.0 meters per second squared for the next 20 seconds. The body maintains the speed attained for 60 seconds, after which it is brought to rest in 20 seconds. Draw the velocity time graph and calculate the total distance traveled during the first 50 seconds and average retardation as the body is being brought to rest. So let's draw the velocity time graph of this body. So we have this is velocity. This is velocity in meters per seconds, and this is our time in seconds. So we are told that a body at rest, that means starting from 0, is giving an initial uniform acceleration of 8. So that means it accelerated for 8 seconds. So this is 8 seconds. 8 meters per second square for 30 seconds. So the time attained there is 30. And we are told that after which the acceleration is reduced to 5 meters per second. The acceleration, that means it's the acceleration reduced by this amount for 5 meters per second squared. For the next 20 seconds. That means 20 plus 30 will give you 50 seconds. So distance time from here to here is 20. And we're told that the body maintains the speed. That means the constant speed. It maintains the speed for 60 seconds. So we have from here 60 plus 50. That's 110 seconds. So from here to here is 60. After which it is brought to rest in 20 seconds. That means the final retardation, 20 seconds. So 20 plus 110, that's 150 seconds. So from here to here is 20. And it's brought to rest in 20 seconds. For 60, after we brought to rest in 20 seconds. So 20 plus this is 130. Draw the velocity time graph and calculate the distance traveled during the first 50 seconds. So this is the information given in the question, and we need to solve. So before we can solve this problem, we must know the maximum velocity or final velocity, which is this. So we apply the equation of motion, V equals to U plus AT. The body is starting from rest, that's 0. Our acceleration is 8, and our time at that point is 30. So V is 240 meters per second. So here now, 240. Apart from that, we also need the velocity after the retardation. So this velocity here. So we have V equals to, so from here now, our final velocity again will now be 240. Our acceleration for this is 5, and our time at that point is 20. But retardation means minus, so we remove this and put minus because it is retardation. So that will give you 240 minus 5 times 20, that's 100. So the total figure will be 140 meters per second. So the one here now is 140. So now that we've done all the information needed, the question now says calculate the total distance traveled during the first 50 seconds. So this is the first 50 seconds here. So we need the distance here, which is a triangle, and the distance here, which is a trapezium. The distance here, this is the triangle. Look at the triangle. And the distance here, which is a trapezium, because the distance for a velocity time graph is area under the graph. So we need the area of this triangle, which is this shape, and the area of this trapezium. So the base of this triangle is 30, and the height of this triangle is 240. The base of this trapezium, that's the A part here, is distance from here to here, that's 140, and the B here is 240. The height of this trapezium is 20. So let's find the total distance, or the distance traveled in the first 50 seconds, that's the distance from here to here. So we have the area of triangle plus area of trapezium. So distance now equals to area under the graph. So we want to add it. Area of triangle is half base times height. So the base of this triangle is 30 plus half base times height. The height is 240 plus half area of trapezium, half into bracket A plus B times H. That means A here is 140, B here is 240, and our height is 20. So let's finish it up. We have 2 in 30, that's 15 times 240 plus, we have 2 here, 2 in 20, that's 10. So let's add this up now. 140 plus 240 that's 08, that's 380. So 380 times 10 was 3800. So let's finish this up. We have 15 times 240. So we have 15 times 240, that's 3,600 plus 3,800, so plus 3,800, so that will give you 7,400 meters. So the distance covered in the first 50 seconds under the velocity time graph is 7,400 meters. I hope you have gained something in this video. Let's see our understanding of the topic by solving the second question on the board. Average retardation as the body is being brought to rest. See you in my next video. In case you need our physical presence, the address again 4 Megalapochiti Crescent, Berigbe Road, Ikorodu, Lagos. Or you want to connect online so that we can have one-on-one teaching with your word, or you are the one listening to me directly. The number is displayed on the screen. Bye for now. See you in my next video. Bye.